the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New and Geocentric Consultants Hugo New Corporation Sustainability Seminar Series, co-sponsored by Brown and Caldwell, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Thank you so much. And I definitely want to open up at the end for questions. So as you listen today, think about if you have questions, and I would love to share. Well, I do want to share a little bit about myself first, just so you know who I am and where I'm coming from, and then also to caveat who I am not, which I am definitely not a sustainability expert, but I appreciate the practice very much and have learned from experts, and I want to continue to learn more. So who am I? Well, I am a kid that was a dreamer, and I think I call it a steamer. In the third grade, I made this paper mache doll of what I wanted to be when I grew up. And the reason I believe that I could become an astronaut is because my parents, who both had degrees in science and math and had also been teachers, were talking to me about Sally Ride. And as we all know, if you see someone who looks like you doing something that you think is cool, you can believe that you can do it too. So thanks to Sally Ride and the women, the American women at NASA, I believe that I could grow up to be an astronaut. But then, as all of you know, you have to go put in the hard work. And so this picture shows me in middle school attending space camp in Huntsville, Alabama. And that particular week was April of 1990. And in April of 1990, the Space Shuttle Discovery was carrying the Hubble Space Telescope into space. So I spent the week with like-minded students, having fun running through simulations, being both a flight controller as well as an astronaut, but also learning about the Hubble Space Telescope. Now that will become important later. So I continued to be involved in STEM through high school. And then, as you heard, I went to Whitman College in Walla Walla, Washington, which was a small liberal arts school. And I decided to study geology. I fell in love with the topic my first year and worked on some internships. This particular one, I spent 5 weeks outside of Yellowstone mapping the last glaciation with students from around the country. And I knew that I was hooked on geology and being a scientist because it brought me together with people from all over with different experiences, trying to solve problems, and then really challenged me. So I left Whitman thinking that I would eventually go on to get a master's and PhD in geology. But first, I had applied to the Peace Corps and been accepted to teach English as a second language. As we all know, there are curveballs in life. And Kazakhstan, the country I'd been assigned to, pulled away from Russia, and I was no longer able to travel there with the Peace Corps. So I had to decide, well, what am I going to do? And I still really wanted to just take a step back and kind of look at the world for a while before going into that master's and PhD. So I stepped back and I became a high school science teacher. I enjoyed teaching earth science to students in Vancouver, Washington, across from Portland, Oregon. And I even started an astronomy class. That's how much I enjoyed science and sharing the topics with my students. And it was in that astronomy class that one of my students asked, how do you go to the bathroom in space? And I didn't know. And I think it's important to say, I don't know, and it's important to be curious. And so my curiosity led me to go to the internet. And in looking up how you go to the bathroom in space, I found out how you do it, but also I found out that they were hiring teachers as part of the NASA astronaut class of 2004. Oh my gosh, they were hiring teachers to become astronauts. That was incredible. So of course I applied, and during the interview process, I actually got to see the model of the space shuttle toilet. We're going to talk about a different toilet later, and learn how it operated. So I had to take this picture for my students to tell them about the week of my interview. And I had the opportunity to actually fly in space. And so as I told you, in April of 1990, when I had gone to space camp, I came home and built the model of Discovery because I was so excited that Hubble was going into space. Well, almost 20 years later to the day, I flew on Discovery as a mission specialist. So I just want to remind you that a lot of the things we do in life, we have to wait. And during that waiting time, we're working towards our goals and dreams. So as students, I just want you to always know to pursue excellence and be curious and be patient too, because you don't know what's going to happen 20 years in the future. Well, I was an astronaut. I worked and flew in space with the STS-131 crew. We did carry 6 tons of equipment to the International Space Station as the second to last major shuttle resupply flight before we transitioned and retired the shuttle and transitioned to new commercial vehicles. And so this is the crew I had the chance to train with for a year and a half and really get to know as wonderful colleagues and friends, and then of course to fly in space with. In 2014, after having been at NASA for 10 years, my family and I decided that it was time to retire and continue working, but to go back to school and become a geologist. And that is then how I got to start working at Geocentech, and that now I am currently a consulting geologist with Geocentech. So today I want to talk about the spaceship that we live on and the lessons that I learned from the International Space Station spaceship. So I took this photo when I was in orbit, and it's one of my favorite photos because it shows both spaceships in the same snapshot. Also, I was helping talk to my crewmates outside as they were doing a spacewalk, and sunrise was just getting to happen. So we, of course, on our spaceship Earth have everything that we need. But as you know, and are continuing to learn with your program, we have to manage what we have and be careful with the resources because it has impacts and we have impacts. And the same is, of course, very true on the other spaceship. So at the time I arrived at the International Space Station, it was roughly 10 years old. Now it's over 20 years old, and it has been extended that we will work with our international partners into the 2030s, which I think is very exciting. But it was a young spaceship. It was just getting started. And some of the things that we were getting were a water recovery system and air revitalization, which we call fancy as the Environmental Control Life Support System, which is ECLSS for short. We use a lot of acronyms at NASA. Today, I'm also going to talk about alternative energies that we used in space that you're very familiar with here too. I just wanted to share about how it's used in space. And then also talk about the lessons that I think we all know about resource management and waste reduction, but how it was driven home when I was in space, and then how I continue to try to change my life back here on Earth and make influences there. So let's start out with water recovery, because this system is very impressive and it continues to be upgraded. In fact, I was sharing just before the talk that I had to upgrade my presentation because in the last 2 years, the water recovery system has undergone some improvements that make it even better. And so let's talk about, seriously, how do you go to the bathroom in space? And it is different on the International Space Station than it is on the space shuttle. The space shuttle was designed as a vehicle that would, maybe maximum be in space for about 2 weeks. And so our toilet, it was useful, but it wasn't answering the second question, which is, how do you keep the astronauts alive, but reduce the costs that would be associated with actually flying fresh water up to the astronauts, and also air, which we had to do for a while. But then by the time the full ECLSS system was coming on board, like I said, right around 2008, which is 2 years before I flew in space, we were starting to make the system where we were recovering 65 to 85% of urine and water vapor, so our sweat and the vapor we breathe out, back and use it. So how does that all work? Well, here's the fancy diagram with all of the acronyms. No, I don't want you to spend a lot of time deep in the weeds. I think the biggest piece I want you to take away from here is that a lot of engineering had to be done, and it continues to be improved. And so we went from, and in fact, when I was on board, we only had one space toilet. Now they have 2, which is fantastic. So we were able to go from urine in, and there's treatment systems that help break down the microbes and make, that's the pre-treatment that you see there. It's fancy urine processing systems. And anyway, it gets to the water processing assembly, which is important because then it is going to purify. So it's going to take all of this urine and other wastewater in, or humidity from the cabin, like I said, and it's got purification systems that then make it where we can have potable water, also air, and then I'll talk about the whole recovery of the Sabatier. So some additions that have just more recently happened, the urine processing assembly in 2020, so this part in here, like I said, early on, we were only able to recover about 65 to 85% urine, but because of the upgrades in this assembly and also the brine processor assembly, we're up to recovering about 93 to 97% of wastewater. That's impressive to me. That means we're saving so much money and resources to just recover on orbit. And we'll talk later about how this has implications back here on our spaceship. Additionally, I know people often want to know what is going on in that wastewater processing assembly. Of course, there's separation of the gas coming out of the exchanger. So there's that separation. There's filtration of just particulates. And there's multi-filtration beds, which are removing dissolved contaminants. And then there's also catalytic oxidation reactor, which is removing organics. So those are the bigger processes going on there. Then I would like to look a little bit more at the oxygen generation, because those were coming up right about the time I was arriving on station. So this shows you that there's a lot of racks, and a rack is about the size of me, and about 3 or 4 feet wide. So this does take up quite a bit of space in space. But again, it's been so significant in helping us recover water and make air, and also scrub out carbon dioxide. So in a volume of something that's probably about a little bit bigger than a small minivan, this is where these different assemblies and racks and even the double-walled toilets are. And for the oxygen generation assembly, again, we were taking clean water from that water processing assembly, and we have electrolysis. And so the hydrogen used to be vented overboard, but when my crew brought up Sabatier, then we were able to have the hydrogen go into the Sabatier, combine with the CO2 that was coming off of our carbon dioxide removal assembly, and only vent over methane, but then also recover more water for the oxygen system. So we started having a pretty, really good environmental control system that now was also providing the crew members with oxygen as well, and getting rid of the carbon dioxide. So this is the system that I wanted to share with you. And it was designed at Marshall Space Flight Center, and it took years of engineering. And then, as I said, it in 2008 was originally starting to be flown, and it was available to my crew, but it continues to have upgrades so that we do even better. Because as we look to going back to the moon and having astronauts working above the moon in an orbital system, well, we're going to need to, again, have these operating systems that are allowing us to recover and not keep flying consumables. So the humor always was, and this was the crew that brought up the first parts of the system, was that today's coffee is tomorrow's coffee, is the next day's coffee, etc. So we have to have a little humor, but it's just a fantastic system. Okay, so back here on Spaceship Earth, the processes and some of the engineering, of course, is always shared. I think that's one of the great things about working at a government agency, is the sharing and making things available to others. And so there are companies that are using things that have flown on the International Space Station to make water recovery better here on Earth. And Aquaporin is an example. And I want to point out, as lifelong learners, you can learn about these improvements and about the companies that are using them in the latest edition of Benefits for Humanity. So NASA makes this available, and this is from the 3rd edition. So if you want to learn more about the forward osmosis and the companies that are using that technology, you can at least start here. Also, in the past, and has been used where there's need for aid and disaster relief, the ISS engineers worked with the folks of Water Security Corporation, and they made it where they can have water purifiers in areas where people need it instantly. And it's kind of a neat story. Again, it's also in this Benefits for Humanity, but it's something where here people on Earth had an aha, because they knew about actually a sibling's work at Marshall Space Flight Center. They knew about the water recovery system and the oxygen generation system. And so they collaborated. And I just think that's really neat too, that again, people having aha moments and then making the lives of people here on our spaceship better because of something that was done in space. And that's always been a goal of NASA. Those are the lessons that I learned from the water recovery system and environmental control system in space. And next, I would like to go to energy. Again, I'm going to look first at the space shuttle and the technology we use there. And then we'll look at the International Space Station. And once again, there's been upgrades. So, of course, I did most of my training on the space shuttle, although we did some training on the International Space Station because we docked and lived there for 11 days. But we weren't in charge of that vehicle. That vehicle has its own commander and engineers, and we were just utilizing resources, and really we were being space movers because I told you we had all of that equipment in this back kind of silver module that we had to move over. And then also we were fancy trash removal systems too, because we had a lot of waste to collect. But anyway, most of my time at NASA was spent simulating and working with the shuttle. But of course, I also learned and trained on the International Space Station systems. So the space shuttle, it provided all of its electricity using fuel cells. And these fuel cells, this is an engineer putting one into the payload bay. So this is the payload bay, this big part that's exposed to space. There are 3 fuel cells on each shuttle, and they're connected both to hydrogen tanks and oxygen tanks, of course, separated. The fuel cells in the middle, and it also has potassium hydroxide as a membrane. And then, of course, the energy is created when the hydrogen and oxygen meet safely with this membrane, and water is produced, and we drank that water on board. So the oxygen was also, the tanks were bigger because of course they're supplying the oxygen that we breathe inside the shuttle. And then there's nitrogen tanks in the payload bay too, because we learned from Apollo, and we have an atmosphere inside the shuttle and space station that is mostly nitrogen with oxygen at about 20%, just like here on Earth. So that is how the space shuttle created its electricity. And it was impressive. There was a lot of copper wiring on the space shuttle in the payload bay, and it made everything on the shuttle go. And we had both a direct current and alternating current systems. So this is the cockpit. I spent a lot of time simulating. One of my jobs on the space shuttle was as the flight engineer that sits right behind this pedestal here. So the commander is here, the pilot here, and then I was back behind them. And the electricity system, since it makes everything go, of course, in simulators, the teachers want to break it all the time and see how you react. And the all the switches for the electrical system are over here. So they become a part of the responsibility of the pilot and mission specialist to work in these simulations. Simulations are great for training astronauts, and that's not really what we're here to talk about today, but it really was some of the fun part of teamwork once you got over the fact that they were breaking things on you all the time. Now, let's go to how the International Space Station creates electricity. Slowly over time, these different solar panels were flown up to the International Space Station, and then they were put into this configuration, which they remain in today. But it's amazing when we were docking to the International Space Station, how big it appears. Because of course, again, in simulations, we've just had a digital rendering of what the space station looks like as you're approaching to dock. But when you actually come up, this is about the size of a soccer field. And you can imagine our vehicle approached and docked to the front there. And it's just amazing. At one point, I had to stop kind of looking out the window. It's so just, it's distracting. It's really big. But anyway, of course, solar, you're familiar with it. The biggest thing, of course, from the International Space Station is how do you store when the solar panels are not in full sun? And so, of course, just like here on Earth, batteries are one of the ways that we store the electricity. Again, another upgrade on board the International Space Station. So here, one of the astronauts is putting in new batteries. We went from having nickel ion to lithium ion, and that will extend out, they think for sure, another 10 years, if not longer. So we've had to upgrade the battery system, and we face that same challenge here on Earth as we have more and more solar power, which is great, but we also, how are we storing it and making it available when we need to have it when the sun's not shining. So back here on Spaceship Earth, again, all of us know that there's more and more research being done, and we also witness that more hydrogen and fuel cells are part of possible vehicles in the future. Definitely solar, of course, we all know is part of private industry and local grids and bigger grids. So just more and more reduction of our non-renewable energy sources and more reliance on things that are renewable or cleaner. And then the resource management, it just really comes down to me that we have to use less and reduce what we need. So again, I talked to you about how we were flying up 6 tons of equipment in this multi-purpose logistics module. And that was to pre-position the crews after us to have food, clothing, science, even a bedroom, and some other very cool things that were for science experiments. And we still need to fly food and clothing and other consumables to the International Space Station. But we're getting better about what we fly. And we have new vehicles that once the space shuttle was retired, then took over that job, and they work differently. So SpaceX, the Dragon, it can both fly to space, delivering equipment, and then like the space shuttle, it can return equipment to Earth. And that is important for science experiments, especially biological, where astronauts have, donated their blood for studies, and urine and saliva and other science experiments that people want to get back. It's also helpful when you want to understand why big pieces of equipment broke, or you want to fix them and you can bring it back to Earth if it can't be fixed in space. So having SpaceX to take over from shuttle, where we were able to also still return equipment, has been important. Northrop Grumman has the Cygnus vehicle, which also supplies things up to the space station, but it operates differently in that it doesn't return this equipment. This vehicle burns up in the atmosphere, and so it should just be mostly filled with waste. And there is waste on board the International Space Station. Of course, one of the things that we learned how to do is separate our trash. So we have wet and dry trash in space. And wet is going to have to do with food. So I'm flying fast food, right, at 17,500 miles per hour. But these are food boxes. Most of our food packages come in little plastic bags that then, and all the air has been removed. It's mostly freeze dried, or there's also stabilized foods that need to be heated, or in this case, this is the space shuttle's water dispenser. So this water came from those fuel cells. And on the International Space Station, the potable water is coming from the water processing assembly, and it's in something that's similar. Essentially, you're going to take your bag of food if it needs to be rehydrated, and you will attach it into this area here, and it's gonna puncture, and then you put out how much water you want in your food, and you can clip it into something that will transfer heat, or if you want it cold, like let's say it's strawberries or something like that that you're rehydrating, then it will be ready in about 4 or 5 minutes, and it's pretty good. But anyway, that wet trash, here on Earth, we might open up food and not consume all of it. That's just not going to really work in space, because then that stuff that you didn't consume is going to start growing interesting things, right? And that we don't want the molds and things that to build up, because it could create toxic situations, or just not healthy situations is the biggest thing. And also, it's just not good, right? Like, you have spent a lot of money to send that food to space. So again, like, my daughter was 3 when I flew in space, and I would always tell her, like, you need to eat everything on your plate. But literally, astronauts need to eat everything in their plastic or whatever they're eating out of. They need to eat it all. But there's going to be residue, and that's the wet trash. And we to pack it up as tight as possible, of course, we use gray tape, which is also duct tape, and we just tape it up really tight, and then we put it into an area that's going to be vented, and that way we don't build up smells, and it's just not so unpleasant. So we have wet trash, and then dry trash, we do better and better at not really accumulating too much of it. But dry trash would be like paper or the tape, or here's an example that you don't think about here on Earth. But when I comb my hair, and it would float out and around in space, but in orbit, I would take that gray tape, stick my hair to it so it doesn't go floating into my crew members, and then throw that into the trash. So separation of trash, and it builds up, and so then we take it away in our vehicles. Also, we have waste that comes up around the equipment we fly. So here, this is going to actually be not a payload, but is a piece of equipment that was going out on a spacewalk, and had to have all this foam around it to protect it on the loads, from the launch loads. We're looking at and getting better at how to pack things. So this created, as in this other frame, just a lot of things you had to manage, right? A lot of waste and keeping track of. That's something that we also are familiar with here on Earth. Too often our mindset is, oh, it just goes to the dump, but really, more and more we're learning we have to live and manage our waste. Well, some new things that have flown after I went to space that make me excited about the way we're thinking is, one, we flew a 3D printer. And that allows us to, instead of spending all this money and energy to launch things to space, make things while we're there that we actually need. So for example, one of the first things that was made was a wrench, because this, if you can make your tools, and only specific tools, rather than flying a whole kit. And yes, we do fly and have kits of tools on board. That's so much more manageable, and especially as we're thinking about going further out into space. So 3D printing, and then what if that waste that I was telling you about, those plastics and all of those things, what if you could use those to actually make some of these refabricated or these tools? So there was an experiment called the refabricator, and this is being installed here by Anne McClain on orbit. And that is looking at, how can we think differently, not only in space, but also back here on Earth. So just really, I wanted to focus on bringing that back here to Earth. Is we have to do better in reducing, and managing, like thinking about like how, instead of having all of this waste, how can I reduce that, and not just think that it goes to the dump? And then how can I make things out of waste that's useful for the future? So hopefully you have a little bit of insight now to our water recovery system and how it's been improved and upgraded and allows us to recover almost 97% of the water on orbit. And of course, I know you know about alternate energy, but just kind of rethinking about it, and its significance, especially into the future. And then waste in space. It's just, it's something we all have to deal with, but we can do better. And reduction is a big piece of that. Well, I had the most incredible opportunity, like I said, for those 15 days in space with a fantastic crew to work with. I did fly just the one time. I really enjoyed it. And then when the shuttle was retiring, I stayed for a little bit longer and then decided, it's time for my family to go back to the Northwest where we wanted to raise our daughter, and where I wanted to go back to school and do my geology. So now I am a geologist and I love working for our spaceship Earth. And I enjoy working at Geosyntec because I get to work with experts and practitioners in some of the things I just was talking to you about. Water will always be really important to me. And I do get to work on groundwater cleanup and also in soil and sediment cleanup. But I work with so many talented people, some who you have heard from in the past at some of these sustainability talks, and others that you'll hear from in the future.